Okay, in this video, we're doing normal probability distribution. So just know that in this video, we have two very important things, which is our mean, and we also have our variance. So these are very important. We're going to use them a lot throughout this video. So, and this, just know that this notation is what you're going to use a lot, which means that if they're still stochastic, which is the still let me just, I don't know how to like pronounce it properly, this word, um, um, variable, that. So this will be it will be expressed as that, and then it is normally distributed around the mean and the variance. So they'll just give you that, which is, I usually, let me just write it how I usually write it. Okay, so this is important. Most of the time, they'll give you the mean as 0 and 1, and this just means that ignore it. Okay, so as soon as the mean is a specific value either than those two, don't ignore it. You have to work with it. So, which is basically you have to standardize it. That's the term you're going to be used. So, if it's another value, then you standardize. If it's a value in this scenario, it's a value either than 0 and 1. So here you have to standardize it. I'll show you how you standardize it. So standardize it. So when you standardize it, I'll actually explain everything from there, how to like basically do it. But I'll show you now. So this is the formula that you use, which is z equates to x value that's given in the question minus mean divided by standard deviation. So that's not a, that's just standard deviation. So which will be the square root of this variance. So note that if it's 0 and 1, the mean, if you in any number that's there minus 0, it will be that number, and then divided by the square root of the variance, which is 1. So that will just becomes 1. So you just basically say x divided by 1. That's just equates to x. So you don't need to do that. Okay, so now let's go on and look at what are the characteristics of normal distribution. So the normal distribution follows this very famous curve, which is always associated with probability and stuff like that. So in this curve, you have this is called the bell-shaped curve, and then they say the normal curve is a bell-shaped, symmetrical around the mean. So this will be your mean. So but right, this is the mean, and then they say around the mean, and the curve approaches the x-axis without ever touching it. So it's an asymptote around the x-axis. So these are the x-axis, and then the total area under the curve and above the x-axis is equal to 1. So that's the whole total from this part, just the total area of this whole thing. You'll understand why it's like that, because 1 represents 100% in any case. So it represents 100% in any case. So that's why it's very important to know that the total area around that is 1. And then the mean and the mode, the median and the mode, these are the characteristics of that. And then 68 of the area under the curve falls within 1 standard deviation of the mean. 68 of the area under the curve is between the mean minus the variance, and then the other one is the mean plus the variance. So that these are the things, like, you don't necessarily need to know these things for the test, but it's just to know if you want to know more. And then 95% of the area under the curve falls within the 2 standard deviation of the mean. And this is how you express this, what they're talking about here. So it will be just the mean, and then it's minus standard deviation, and then here it is the mean plus standard deviation, and then the next part. So this is the 68 part. So let's just put it as 68 part. So this part is 68, and then this part, the next part will be which is 2 times the standard deviation, and then this part, hope you don't lose track here, this part will be your 95 part, which is that mean. Just write that nicely. So that will be mean minus 2 times the standard deviation, and then the rest of the part, which is 99.7%, which is let me just put it here, which is will be, let me just separate these guys so that you don't get confused. This one is the plus, which is 3 times the standard deviation. So it's the same thing with this side as well. So I don't want to show it that side because it will start looking very complicated. So that's the area there falls within that, this falls within that, this falls within that. So you just have to know this is 99.7%. So on either side, basically. So the graph is symmetrical around those two sides. So okay, now let's go to what do you call it? To standardizing and basically working with the formula. So I already explained what standardizing is, and this is what's very important. So you just need to know this is the formula you're going to use when you're standardizing your equation. So it's x minus your mean divided by your variance, right? And let's say so now I told you that you need to just ignore this when it's like that, when it's like this, of 0 and 1. You see in questions why you should ignore it. For now, just accept that you ignore it. And now let's look at the of like how you work with probability, what do you call it? Probability equations, like for instance, P of Z greater than Z. Let me just, for the sake of this video, let me just put this as A, right? So this is the first rule. So these are the rules that you follow when you're calculating probability. Note that every time you have to work with this, the ideal way, this is like the ideal way of working with it. It has to be Z less than A. So note that this is like the idealistic way of working with it, right? It should be in this way. If it's not in this way, you want it to be in that way. So to get there, if it's just greater than, you just write the complement, which is 1 of P of Z less than A. Note that in this one, you don't have to put in equal to A. You just put less than. You don't have to put equal to. So just note that in Poisson distribution, in normal distribution, in Poisson distribution, discrete distribution, and also in the other ones, you have to put equal sign. In this one, you don't have to do that in normal distribution. So don't get confused there. And the second rule is if P of Z is less than negative A. Now, in this one, you just say P of Z is greater than A. That's the first part. So now note that it looks exactly like this one. So what you need to do now, you do the complement. So you end up with P, which is 1 minus P of Z is less than A. So that's your final answer. So from this point, you can literally just jump to the answer is that one. And then for number 3, which is P of Z is greater than negative A. So for this one, it's very important for you to just, you know, remember you have to just flip this sign. So it's P of Z is less than A. So that's how you change that negative sign, because you always try to work in that state. That's your idealistic stage. So whenever it's like this, then you can find it in your probability in a normal standard normal probability distribution table at the back. So now let's do the more complicated ones. So this is the 4th one. It's P of A less than Z less than B. Okay. Now, whenever you have 2 of them at the same time, you just have to say P of Z is less than B, which is the last one, and then you say minus P of Z, it's less than A. So in this one, it works nicely because they're both in idealistic stage, because they're both less than. That's what is important. That's what you just need to focus on. They're both less than, so that's very important. Now this one is correct, so you can find your probability at the back. This one you can find the probability at the back. So for the next one, it will be a little bit drastic, because then you have to get the values. You can't just get the values after you just made that formula. So this will be P of Z is less than B, and then this is minus P of Z is less than negative A. So note that this one follows, this one is the second rule, so you need to just write 1 minus P of Z is less than A. So from here, everything just follows that formula, those 2 formulas at the top there, or the third one, depending on what you're working with, and Z of less than B. Just don't like those pop-ups. So now you have this formula. So this will be your final formula. Wait, made a mistake here. We need to just distribute that thing there inside. So it will be plus that one. So it will be P of Z less than B. And then this will be plus P of Z. Make sure you understand this part because it's very important. Minus 1. So this is your final formula that you will use from this guy. So you can literally just jump to this one immediately whenever you see that. So just know that it's P plus that one minus 1. So you just know that you just have to minus 1. It's something minus 1. It's that one plus that one minus 1. So let's try it when they both negative. So number 6, when they both negative, P of A less than it's negative A less than Z less than negative B. So this will result in, let me just say, do it for yourself and see how you get to this answer. This will result in this. Doesn't matter which side you write it. Sorry. This will result in this. I want you to just prove it for yourself that this is true. There's 1,000 ways to do it, but just make sure you understand how you get to that final answer. So now you got the hang of the probability equations. Now you need to know how to basically you learn how to work with the different probability thingy. what do you call them? The numbers. Like you need to just know how to work with how to get your probabilities when you're given a specific question. For instance, let's say P. This is a question. So let's say calculate the following probability from standard normal table, and then you just say it's P of Z. It's less than 0. So now you have your idealistic stage, which is at the back of the table. You know that at that point where you have 0 and 0, you have 0.5 here and other numbers here, numbers there, numbers there. So this is 0, this is 0 point, this is showing as 0 point, just do this, 0, 0, 1, this is 0.02, this is 0.03. So these are the numbers that are there, they are put there. So that one I know of by heart, that is 0.5. So it has more zeros there, but anyway, so that's that point. So the answer is just the probability of that is just 50%, which is 0, 0, 0. Just put it to 4 significant figures. That's just 50%. So now if you continue with working out the other values, for instance, the more interesting one is P of Z. It's less than 1.15. So for this one, you're going to have to move on to 0.1 until you get to 1.1, and then you move on to the fifth block, which is about here. Let me just do this. 0.4, 0.5. So you have to move on to the fifth block, which is so it'll correspond with this one. Now you have to focus on this answer. So let's go to that table. Just want to move on to that table, to the T tables real quick. Okay, so now this is what I was explaining there. So you have your standard normal probabilities, and then these are the values that you're looking at. So you're looking for 1.1, 1.15. So it will be this value. Let me just highlight it here. So that's the value you're looking for, this value, which is 0.8531. 0.8531. So the value that is there, it's 0.8531. So the answer to this question is basically sorry, it's the bottom one. Didn't see that now. Almost made a mistake. So you see how easily to make a mistake is. Didn't trace it well, so you have to drag it to that point. 0.749. That's the upper value, so 0.8749. So that's your final answer. So it's 0.8749. So it's important to just double check before you actually conclude your answer, because in these things there's no one who's a master of this thing. You can easily make a mistake. There's always a human error in this type of questions. So basically this is what you need to know about normal distribution. And when you need to standardize it, they'll always tell you this is what you need to standardize for. Like in between, let me say you have what? So you have a number between 280, 250, and 280, and then this is in between. So you know that it's just basically Z. of that one. And then this always tell you that this is the mean, which is will be something like maybe 248. That's the mean. And then this tell you the standard deviation is 12.45. Then you have to get the square root of that. So that now you just have to work out this one as p of that one. So you can either do it here and just say it is 250 minus sorry there minus your mean, which is 248 divided by square root of 12.45, and then this is less than z, less than the same thing but with that 280 minus 248 divided by square root of 12.45. So if you work out this thing, it'll come out to, let me just try to work it out. So it's 250. This is what I just made up right now, but you see it in the divided by square root of 12.45. So this gives you, note that this is still inside bracket of p. So this will be simplified as 0.56. My advice is to just work it out to two significant figures. So 6, 7, and then this will be less than z, and then my less than, if you work out this part, it will be 8 divided by square root of 12.45. That's 9. Whew, that's a very big number. 9.06. Let me just write it as 7 again. 7. So our thing goes up to 3. So we can't unto 3 point something. So we can't really find for 9. However, in your question, they will never give you such a high number. So you just have to look at that. But online, you can find this value online, the value probability. And then from here, you just apply. So you can see now your values similar to this one. So you always just apply those rules, and then you get your final answer. So that will be P of Z is less than 9.07 minus P of Z is less than 0.57. So this one you can find from the table. This one you can't find from the table, on the table that's given to you. So you just need to just if you get a value that's greater than that one, just have to basically figure out how to just find it on the table. Okay, but this one will be close to 1 basically. Okay, now so it's 0.99 point something, so we can estimate it to be like that, and then this one will basically give us 0.57. It's the top row. 71.5. This is 0.7157, right? 0.157. Okay, so now I'm approximating the answer. So this will be 0.99999, and then this will be 0.7157. So the answer will be 0.2843. So that's your final probability answer if the thing was in between these two values. Okay, So this is all about, so this is when you standardize it. This is when n is given as 2, 4, 8, and then the variance is 12. Just remember that it's 12, 45. Okay, so this is all that you need to know when you're standardizing something. I mean, I will do past paper questions later on. For now, you just need to know this type of thing. So enjoy the semester test or whatever you're preparing for at the moment.